Hello, Goal Venture students, and welcome to your pre-trip work. Here's Rihanna. All right, so what are the objectives going to be for this? We're going to learn about the history of Gob Valley. I'm just going to call it Gob Valley from now on. The historical geology of Gob Valley, some bad boys in 2013, plants and animals of Gob Valley, wind and water erosion specifically for the area we're going to, and we're going to learn what in the heck a gosh darn hoodoo is. All right, so let's get into the history. So obviously native peoples were there first. Then came some cowboys. This wasn't like very highly recorded, but cowboys we know were there. Then in the late 1920s, a guy named Arthur Chaffin, he was the owner and proprietor of a ferry company, and two other fellas were looking for an alternate route between Green River and Caneville. So they found this awesome, crazy Walt Disney looking place, like kind of right between those two cities. So they called it Mushroom Valley, and in 1949, Art went back to Mushroom Valley. He explored it and took some pics, kind of, helped educate the public about this place. He probably took a selfie or two. And then in 1950s, this place gained some public interest. Utah ended up purchasing it between 1950 and 1964, and in 1964 they turned it into a state park. So smiley face, because that's cool, because we get to see it now. So here's just a little picture of where they went. This is Green River, this is Caneville. So they're looking for like a more direct route this way. I imagine their ferry company was like this, and then it kind of went this way or something, I don't know. But in this little circle is Goblin Valley. You can't really see it. Here's Arches. So we were there in Thanksgiving time. Okay. Next. So let's go over the geologic history of Gob Valley. So the bedrock of this area is Jurassic sandstone. So that means it was deposited in the Jurassic time period. That was about 170 million years ago. So that's a long time. It's called Entrada sandstone. So there are different layers of rock that were deposited over different time periods, and we have different names for all of them. So what these hoodoos usually are Entrada sandstone, which is created by debris that has been eroded from ancient highlands, so large plateaus were eroded over a long period of time, and then redeposited on an inland tidal flat. So they think that Goblin Valley, that whole area was inside of a inland sea, and it was more of a tidal area. So it was kind of like the coastline of this inland sea. So over time, like a long time, and because of the tidal nature, alternating layers of sandstone, siltstone, and shale were exposed, and this Entrada sandstone, was deposited on these alternating layers. So you can see this with your very own eyeballs. I'll give you some examples. And the rock formations there show evidence of ebb and tide. Like I said, they thought it was a tidal flat, tidal channels, and coastal dunes. So it might have been a nice little resort area 170 million years ago. So here is what I was talking about. You can see the layers right here. This is most likely a newer layer of sandstone, but this down here is probably that 170 million year old Entrada sandstone. And you can see layers right here of deposition. And then these long lines going vertical is just erosion from water. It's created a rill. And you will learn what a rill is later. So here's just a good example of those formations. So we're at Moab. This is pretty much Moab's formations. So they got Chinle, Wingate, Kayenta, Navajo, and Entrada is at the top. And this is where you see the Arches at Arches National Park. Then you've got, sand dunes. So you can look at all this stuff and kind of get a feel for how long and how old these formations are and how long it's been taking them to form. And so right here, we have Entrada sandstone. This is the Jurassic time period. So that's a long time ago, 170 million years is right about here. And then we've got more layering happening as the future goes on. So let's talk about the bad boys. In 2013, some silly Boy Scout leaders decided to knock down a hoodoo, and they videotaped it, which was great for evidence. So they said to the court that it looked ready to fall and it was dangerous to other visitors. So this is a good example of ignorant bad boys, because let's drop some knowledge. Hoodoos have existed for millions of years, which is a very long time, and the average rate of erosion for a hoodoo is 2 to 4 feet, wait for it, every 100 years. So the likelihood of that hoodoo falling is very, very low unless it was under 2 to 4 feet wide. And, I doubt that it was. It could have been, but, if it's 2 feet, it still takes another 100 years for that thing to fall. So just let it happen naturally. Don't kick hoodoos. So these bad boys got in a lot of trouble. They got 2 felony charges each. They were later dropped down to criminal mischief misdemeanors, but that stuff follows you for your whole life. So that was one silly mistake that they made that really impacted their life. So let's talk about the plants and animals, or flora and fauna of the area. So flora, or plants, we've got Mormon tea, Russian thistle, cacti, juniper trees, pinyon pines, and Indian rice grass. So how do you survive? How do they survive, you ask? They adapt to survive. So some adaptations that these plants have are a waxy cuticle to hold water. So it's kind of like, they call it a cutaneous layer around the leaf. But really, if you look at your cuticle, it's kind of like different. It's looks more like cellulose. That's kind of what they have around their leaves. So that holds in water. There aren't a lot of holes for that water to be able to leave and transpire up into the atmosphere from. They also have small leaves to, again, hold in water, kind of conserve energy, and they have thorns to keep pesky little things away from eating it, and etc. They've got all sorts of adaptations. So the animals that we're talking about are jackrabbits, or jacks, scorpions, or scorps, kangaroo rats, also known as roo rats, coyotes, yotes, lizards, also known as mini dragons, pronghorns, known as desert deer, kit fox, the cutest thing ever, and midget-faded rattlers. You can get that one. So how do they survive, John? They adapt to survive. Some adaptations that these animals have are, many are nocturnal because it's really, really hot during the daytime. They get water from their food, which is really cool. Sometimes more than 70% of their water is from food. Like the kangaroo rat gets all of its water from food. They have crystallized pee, so they don't lose a lot of liquefaction. Their urine turns into a crystal material. So that's, again, the kangaroo rat's a good example of that. Some don't need a lot of water, like the lizards, scorpions, really jackrabbits, coyotes, pronghorn, all of these things don't need a lot of water because they have really thin, gangly limbs that don't require too much water per day. So they can go very long distances. You'll see that with their long legs as well. Usually if they have really long legs, it's good for like heat retention, cold retention, and then the ability to traverse over long periods of time with low amounts of water. And so then there's that heat protection. And then of course, etc. So here's the plants. We've got Mormon tea right here. You can see it only puts the leaves where it's going to get water and sun. Down here, it kind of holds off on growing leaves, conserves energy. It's got that cuticle. Here's a juniper, same deal. The leaves are out. They are up here to gather moisture from the air. They also have a cuticle leaf. This one is the Russian thistle. It moves to move its seeds around, so it's not going to be in the same area, and its progeny aren't going to be in the same area, so it doesn't have to worry about competition. Here's cacti. It's got thorns, cuticle, and then here is the Indian rice grass, and here any sort of wind that happens is going to blow this seed away, and it's going to be able to germinate away from itself. So its progeny will not take up water. Then here we go. A lot of the times in hot areas you see big ears, long legs, not a whole lot of fur. This is due to veins going up and down their body like this to conserve cold. So it's heat regulation and even water regulation. So you can see those long ears, long legs, long ears, long legs, not a whole lot of fur, long legs, long ears, again right there. This little guy doesn't need a whole lot of water. This guy pees crystals, so he doesn't need a lot of water. Again, long legs, long ears. This guy camouflages really well. He gets heat from the environment, so he'll come out during the day. Same with this guy. He can open up these flaps around his belly and gather more heat that way as well. So these are all very suited for this environment. And here's some jackrabbits punching each other. So let's talk about erosion. What is erosion? It is the removal and movement of sediment from a source due to weathering to another area. So in this area, we're going to see a lot of differential weathering. That's when soft rock is eroded due to weathering, and hard rock stays, leading to cool formations. So water differential weathering, a good example is waterfalls. Wind differential weathering, and a good example is hoodoo and all sorts of weird-looking things. For water, when we talk about erosion, you're going to see something called karst topography. Water in the air a lot of the times is acidic. We have carbon dioxide in the air. It sucks up, the water sucks that carbon dioxide up. The water also sucks up dead plants on the ground. That holds carbon. So when carbon mixes with water, it creates carbonic acid, which weathers sandstone and limestone. Conveniently, that's the kind of rock that is in this area. So when that water pools, especially like on the top of caverns, we see holes in the tops of those caverns where light can shine through, and that's called karst topography. Also, a good example is Florida. So there's a lot of sinkholes in Florida. That's karst topography right there. With water erosion, we also see ebb and flow, tides, rills, gullies, and streams, and rivers, and that will carry sand away. So then wind, a good thing to talk about is surface area to volume for wind erosion. So more on the outside than the inside weathers faster. So surface area is on the outside. That's pretty much what everything can touch. And then volume is what's on the inside. So if it has more surface area to its volume, then it's going to weather faster. So then we've got two different things. It's abrasion and deflation. Abrasion is when wind carries sand in the air and hits something. It basically sandblasts it to erode it. And then deflation is just when wind carries sand away from an area. So it deflates that area of sand. And so then here is a good example of rills, gullies, and then they turn into streams and rivers. So this is how valleys happen and how water erosion happens. So what in the heck is a gosh darn hoodoo? They're also called tent rocks, fairy chimneys, and earth pyramids. Differential weathering happens. We learned about that last slide. So harder sandstone stays from that entrada sandstone, and the softer stuff gets eroded away and then carried away somewhere else. So strange edges create more surface area in some spots and gets eroded faster. And so that's why we see these formations occurring the way that they are. And I'll show you a picture of that. In this specific area, we have something called frost wedging, which that creates most of the weathering in Goblin Valley and Arches. Water gets into cracks in the rock, then it expands when it freezes. So about 10% of that water expands, or it expands 10% more than it normally is. And so then that opens the cracks a bit more. And when those cracks open a bit more, sediment falls down. Rain in the monsoon season carries that sand away. It comes down the sides of the mountains or the rock formations. It carries the sand away, and then it also weathers the bottoms of rock formations as well. So then a cool thing to think about in the hoodoos is that different minerals in the layers create different colors. So a good example of like minerals in the layers is dolomite, which is calcium magnesium carbonate, and essentially dolomite really like protects it from weathering. So in the top parts of the spires, you're going to see a lot more dolomite than sandstone, or you're going to see a lot of dolomite in the sandstone. And then there are areas that are more red looking, and that's hematite, and that's iron 2 oxide. And so really all that is it's rust. And so these crystals in the layers become rusted, and you get a good looking red color. So here we go. This is a lot of like stuff that is going to confuse you probably, so don't worry too much about it. But here's where those joints in the rocks kind of weather away in weird angles. So you can see these joints right here. At the top it's going to weather away. You're going to get these weird edges, and then that part is going to weather away faster as well. So then the bottom is going to end up like having this weird mushroom shape. So I don't know if I can give you a better example of that, but That's pretty much what happens, is these parts break off, and then at the bottom, eventually, like, water and wind will start to weather this away because it's more jagged and, like, it protrudes out here. And so then here you can also see good examples of layering. Like, here's a layer, here's a layer, here's a layer. They're all different colors, so you can tell that that sand was deposited at different times. So that's all you're going to need to know. Have fun on the quiz.